Okay. Chemical reactivity. Reactivity of metal that should be increases with decrease in ionization energy and electronegativity. Okay. So that is in periodic table. There should be the left side atoms are belong to metal, and their reactivity that should be proportional to atomic size and electropositive character, and anti-proportional to ionization energy and electronegativity. When their ionization energy value high, means they reluctant or they do not show or they seldom show electron removal from their outermost orbitals. Okay, ionization energy means what? That is the energy required for any atom, any gaseous atom to remove their electron from their outermost orbital, that is valence shell. Okay, so when ionization energy value high, so the energy needed to remove electron from outermost shell, that should be in cases, the amount of energy that should be in cases. So their reactivity that should be decreases. They are seldom reacted. Okay, when their reactivity high, they always, there's less tendency to show, to form into or to transform into cationic character. Okay, so their reactivity that should be decrease. So that must be anti-proportional to ionization energy and electronegativity. When ionization energy electronegativity that should be increased, so reactivity obviously decrease. And that should be, always remember, reactivity of metal that should be increased when atomic size high. So they easy to remove electrons and to produce cation. Okay, and obviously reactivity of metal that should be increases with electropositive character. Electropositive character also same, that is by removal of electrons. Okay, now reactivity of non-metals. Non-metals means that is the right side of metal, right side of atoms which are present in periodic table. That should be increases with increasing electronegativity. When electronegativity that should be high, their reactivity that should be high, because they always, when reactivity high, they attract electron, incoming electron towards its valence shell. So their reactivity that should be increases when reactivity increases, as well as electron gain enthalpy increases, so their reactivity increases. But when atomic radii that should be increases, so there must be less attraction pull from nucleus. So that means their reactivity decreases. That should be inversely proportional to the reactivity of non-metals, that should be inversely proportional to atomic radii. Okay. On moving down the group, the melting point, boiling point for metallic elements go on decreasing. Due to why? Due to decreasing of force of attraction, because shells number can be increases from top to bottom. So their size more bigger and bigger. That's why their attraction pull that should be decreases. Due to this, their melting point, boiling point that should be increases. Okay. Melting point, boiling point that should be decreases. Sorry. Okay. For non-metals, that should melting point, boiling point generally increase down the group. That should be opposite character. Okay. The tendency of an atom of the element to lose valence electron and form positive ion is called basically electropositivity or metallic character. To lose valence electron and to produce positive ion. This event can be called as electropositivity, or this property is called electropositivity or metallic character. Okay. Now we can come in periodic table, that is second period and third period. There must be some similarity can be seen from diagonally spaced elements. Okay, which are diagonally spaced. That should be, as per example, third period group 1 lithium, and then third period that is magnesium. Group second group that is group 2, that is beryllium and aluminium. Okay, boron and silicon. Because if we go left to right, size that should be decreases, no, and all of the properties that should be changes, and top to bottom that is size increases, and all of the properties that should be according to changes. So if we can consider any type of change, that is from top to bottom and left to right, ultimately diagonally spaced metal having no overall change. So that is diagonally spaced two atoms having similar properties almost. But there should be some limitation in diagonal relationship, because after third period there must be diagonal relationship somehow vanished or not seen. Okay. Now we consider for this concept only, consider for second period and third period only. You might read. Then we consider chemical bonding. That is chemical bonding. There should be, we consider, that is all atoms have to tendency to acquire or to find out or to carry their octet configuration for stabilest form. Okay. Means valence electron having 8 electrons. But due to this ionic compound form, due to this covalent bond form, due to this all of the chemistry develop. Okay. But there are some exception. As for example, incomplete octet. That is lithium chloride, beryllium BH2 and BCl3. They are all of the cases less than octet can be seen. Okay. And odd electron species, as we know, if any species bear 8 electrons, there are no chance to find out any odd electron that should be present in species, right? But here odd electron molecules also found. That is NO, that is that is NO2 ClO2 minus and Ag2 plus. Okay. Then we consider expanded octet of central atom. That is PCl5, SF6 and H2SO4 all having greater than octet. That is must be P, phosphorus having 10 electron, that should be must be greater than octet. SF6 12 electron around of it, that is must be greater than octet. Though that is in PCl5 all chlorine that should be acquired 8 electrons fulfill octet. Though SF6 fulfill their octet, but central atom that should be having more than octet. Okay. Metal should have low ionization energy, otherwise it cannot lose its electron, cannot form cation. So obviously ionization energy that should be low. Non-metals have electron gain enthalpy, that is obviously high gain in electron enthalpy. Otherwise incoming electron does not come, and non-metals does not form any types of anions. So that should be need, that is low electron gain enthalpy. Electron gain enthalpy is needed. Okay. The energy released during the formation of 1 mole of crystal of lattice, that is called basically lattice energy. Okay. Okay. Then we consider some compound, that is ionic compound. Ionic compound form due to electrostatic attraction between the cations and anions which are formed. Okay. And they, when dissolved in any solution or molten state, they can be furnishes some anions. Okay. They exhibit as solid state. They are having high melting and boiling point, and as there must be ions are there, free ions, so there must be some polarity differences there, electronegativity differences there. So that's why they are overall polar compounds. Okay. And that's why they are soluble in polar solvent, as for example water, as for example alcohol, so on. But they are normally not soluble in non-polar solvent. Okay. And they, as they molten state and in dissolved state, they furnishes some ions, so ions can carry electricity. That's why good conductor in molten state in aqueous solution. Okay. And have crystal structure. Okay. NaCl, as for example, we know that is having crystal structure. Okay. How we can conclude their formula? If X is the charge of A and Y is the charge of B, then we cross multiply and we consider formula AYBX. As for example, aluminum 2 Al2 SO4 whole 3, right? Aluminum having tri-positive, that is 3 positive. SO4 that should be 2 negative. That is if we combine them, that should be get Al2 SO4 whole 3. Okay. Now we consider how we can mate Na plus Cl minus by theoretical concept, that is bond Haber cycle. There should we consider Na solid and half Cl2 gas. That must be Q. Q is the overall enthalpy change. Ultimately, we get Na plus Cl minus. That is ionic compound. But how we can change? That is, there must be lots of steps. That should be Na solid. S, that is S means enthalpy of sublimation. That should be Na solid to Na gas form. That is sublime can be take place. Sublimation can be take place. Okay. Na gas, then I, that is ionization can be take place. So there must ionization can be take place. So cation formation take place. So I plus produce. That is Na gas to Na plus. That is by I. That is ionization enthalpy. Okay. Conversely, that is half Cl2, there should be half D, that is enthalpy of dissociation. So molecule can be dissociated into Cl, and then minus C, that is electron gain enthalpy, that is electron released. That's why. Okay, that's why Cl minus. So Na plus and Cl minus, that must be minus U. U means that is enthalpy. That ultimately we get Na plus Cl minus. If we combine all of the things, okay. If we combine all of the things, we get overall enthalpy change. That should be Q equal to S plus I plus half D minus E minus U. Okay. Sign are not changed here. Okay. Sign intact as it is. Okay. Then properties of covalent compounds. That is compound. These covalent compounds are based upon mutual sharing. There must be no complete transfer of electrons. Okay. So there must be both of the atoms can give their valence electron, and they should be combined by mutual sharing. Maybe mutual sharing of 1 electron, maybe mutual sharing of 2 electron, maybe mutual sharing of 3 electron. Okay. Okay. They must be produced covalent compounds. There was lots of concepts are there. That is sigma bond, pi bond, bonding, chemical bonding. Lots of things are there. Okay. So compound exists as liquid or gaseous state at room temperature. Okay. Due to magnitude of intermolecular forces. That's why. Okay. And have high boiling point, melting point. Maybe there was boiling point, melting point, maybe higher or lower comparison are there in of ionic compound and covalent compound. Okay. And poor conductor of electrons because they do not contain any free electrons or free ions. Because free electrons and free ions all can be able to carry electricity. Okay. But normally covalent compounds do not furnish any type of ions. Okay. Some covalent compounds can be soluble in water. As for example, we know that is carbohydrate. That is normal table salt. That is, not normal table salt. Table salt is a ionic compound. Normal sugar is soluble in water. We know that. Because of what? Actually, sugar is a covalent compound, organic compound and covalent compound. But there must be lots of OH group. There must be some polarity difference, and that's why hydrogen bonding can be take place in water. So easily they are soluble, but they do not furnish any type of ions. Okay. Okay. So basically covalent compounds are soluble in non-polar solvent. Okay, like benzene, usually insoluble in water. Water as a polar solvent, that's why it does not dissolve in water. Okay. Now we consider formal charge. What is called formal charge? Formal charge are basically called total number of valence electrons in the free atom minus total number of non-bonding, that means lone pair of electrons, minus half of total number of bonding electrons that should be shared. Okay. That is, there must be considered, that is ozone. There must be 3 oxygen having numbering 1, 2, 3. Okay. The middle are 1 and the 2 side that should be conversely 2 and 3. Okay. Formal charge of 2, that is must be valence electron 6, minus 2, that is must be non-bonding lone pair, that is minus half into 6, that is bonding pairs, that is ultimately get 1. Similarly, oxygen, that is number 1, that should be get 0, and there is O3, that is must be similar, that is valence electron 6 minus, that is 6 plus half into 2, that is should be minus 1. Okay, so that is 1 oxygen bears plus 1, other oxygen bears minus 1, middle oxygen having 0, so overall that is net charge, that should be 0, that is the molecule is a neutral molecule. Okay, there should be some bond type. There must be many bonds we can find in inorganic and organic chemistry, but some basics are very much important. As for example, CH, that is 107 picometer, C bond C, that is 154 picometer, C double bond C, that is 133 picometer, C triple bond C, that should be 120 picometer. Okay. Bond order. Now we consider bond order. Bond order, what means bond order? Bond order nothing but that is half of number of bonding or electrons present in bonding orbitals minus half minus, that is antibonding orbitals. That is must be electrons present in bonding orbitals minus electron present in antibonding orbitals by half. Okay, there must overall hole can be there, but there must be some actually bracket is not there must be wrong misconception there. Bond order equal to, if we consider that is half into number of electrons in bonding orbitals minus half of number of electrons in antibonding orbitals, then it can be correct. Okay, there must be wrong. Bond order depends on lone pair repulsion and hybridization of center atom, obviously sp, sp2, sp3. Okay, then bond order that must be equal to half of number of electrons in bonding orbitals minus half of number of antibonding orbitals. We can retain, otherwise we can retain that is bond order equal to whole of number of electrons present in bonding orbitals minus number of electrons present in antibonding orbital, that is whole, then half. Okay, there is some written mistake is there. Okay, then we consider bond order proportional to 1 by bond length, that is bond order that is proportional to bond strength, and that should be inversely proportional to 1 by bond length. Okay, that is must be directly proportional to bond strength and indirectly proportional to 1 by bond length. If bond order is low, then obviously bond strength low, bond length that should be high. Okay, the bond enthalpy and bond dissociation enthalpy that should be are equal value, but their sign that should be different. If one is plus, so other should be minus. Okay, and there must always consider bond order. The formula is not correct, that should be rectify it. That is bond order equal to half of number of electrons in bonding orbitals minus half of number of electrons in antibonding orbitals. Otherwise we have to retain that is bond order equal to number of electrons in bonding orbitals minus number of electrons of antibonding orbitals, then whole that should be inside of bracket, then into half. Okay, then bond order we can also say that is total number of bonds between the two atoms in all the structure, right? Total number of bonds by total number of resonating structure. That should be less popular. Okay, the smaller the size of the cation, the larger the size of the anion, greater the covalent character of the ionic bond. If ionic bond, there must be some ionic bond having some covalence character. Okay, when covalence character generated, when the cation having that is Hertz pair and positive character and more smaller in size. Okay, and anion having more bigger size, that's why bigger size of the anion can be easily polarizable, and that is smaller size of the cation can be easily polarize the anion. Okay, that is explained by Fajan's rule. Okay, then we consider dipole moment. Overall dipole moment, that should be charge q into distance of separation, that should be r. Okay, that the unit is d, that is d by, that is 1d equal to 1 into 10 to the power minus 18 ASU into centimeter, that should be 3.335 6 for 10 to the power minus 30 centimeter. Centimeter, I think kilometer, centimeter, we have to check. Okay, their formula is mu equal to root over mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Okay, if we consider BF3, that is BF3 is a planar, so if in one direction where one BF is there, there must be one dipole, and the two BF bond that should be make overall other dipole. After this, the two opposite dipole can be cancel out each other, so net dipole moment that should be 0 for BF3. Okay, similar, that is CW, there must be two dipole can be generated, and these two opposite direction dipole can be cancel out each other, so mu equal to 0 for CO2, carbon dioxide. Okay, then B.Sc theory, that is valence shell electron pair repulsion theory, that should be indicated. There must be in compound lone pair can be there, bond pair can be